I've been doing these kind of charts. They're topographical map analogs. Where on the north-south axis you'll have a month of the year. On the east-west you'll have the hour of the day. And then you depict a parameter value of some kind, be it a mean, like a mean temperature, or a mean wind speed, or a mean vector wind. I can do those also in terms of arrows. So I've been, I thought it'd be interesting to find out how a climogram of extreme parameter values would be, given the fact that a lot of meteorological distributions are skewed, and that manifests itself at the high end. I thought it'd be interesting to compare what an extremes climogram would look like compared to ordinary means. So I chose 99th percentile for some, and the first percentile for others. And I did this for a number of stations: temperature, variables: temperature, relative humidities, and sustained wind speeds. For the temperatures, I did Pueblo, California, Los Angeles, San Francisco, and Boston. And in a nutshell, the distributions of the high-end temperature, hourly temperatures for Los Angeles are different than they are for the means at most times of the year. And it's got to do with the offshore flow, Santa Ana's. So I think that's kind of interesting. It's quite a contrast. Like, for example, here in Los Angeles, you have in the mean, the maximum mean is like about 74 degrees in August, whereas the maximum 99th percentile is 94 in late September, early October. It's not only displaced to a later month, it's also displaced to early in the day, because you get relatively early in the day, you'll get a sea breeze kicking in that will stop the Santa Ana. Okay, and then I also did extremes of low humidities for a number of stations: Los Angeles, Seattle, Tacoma, Miami, and Boston. Los Angeles is particularly interesting because if you look at the means, it looks like it's pretty much a diurnal pattern. I mean, you get the highest values in pre-sunrise hours and the post-sunset. A little bit of variation from early to late. But then if you look at the lowest first percentile, it's much different. And this is again due to the offshore flow. You got an ISO high of 8% for late October, mid-November, around noon. That of course respects the Santa Ana events from that time of the year. I also did Seattle, like I said, I did Seattle, Miami, and Boston. The contrast isn't quite as stark, but it's interesting that in comparing stations, you have a different time of year in which you get the absolute minimum. And finally, I did extreme winds. San Francisco, upper 99th percentile sustained winds. San Francisco, Chicago, O'Hare, Wellington, New Zealand, which is advertised as the windiest city in the world by some sources, and then also near Marseille, France, which is subject to the Mistral. And I did the contours. There's not that much of a contrast in pattern between the means and the extreme, except for Wellington, where you'll have a maximum around 18 knots in November, but then if you look at the extremes, you can get virtually gale force winds virtually any time of year, any hour of the day, which I think is kind of interesting. And then for the Marseille area, you have the peak incidence of the Mistral. You can get a 99th percentile sustained wind of 39 knots, which is pretty high. So that's kind of what I did.